Alexander Bossard, who is a member of the board of the Department for Industrial Services and Technical Office of the City of Puli. He is coordinating his department and has piloted several smart city projects in the field of big data, mobility, e-government, and open sourcing cooperation with industry, such as Swisscom, academia, and international organizations and other cities. Mr. Bossard, the speech is yours.
Thank you very much. Kalimera. Before talking about water management for smart cities and collaborative open source development, I must say that I'm particularly attached to your beautiful country, where I traveled so many times. And my parents gave me the name of Alexander because of my grandfather, who was an Hellenist professor who wrote several books about Greece and mythology. Unfortunately, he didn't teach me Greek language, so that's why I'm going to continue with Shakespeare language. So thank you very much for giving me the opportunity and the honor of speaking here today, representing the small smart city of Puy, which overlooks the Lemon Lake near Lausanne and Geneva, with 18,000 inhabitants. Water management for smart cities, collaborative open source development. In your opinion, in a city, what is one of the most expensive things? So as I don't have a lot of time, I will give you the answer. I give first a little indication. This thing is invisible. These are the underground networks, such as the drinking water network, the wastewater network, the electric network, the fiber network. For Puy, a little city of 18,000 inhabitants, these infrastructure represent a value of 300 million euros. That means that maintaining this value of this asset requires annual financing between 3 and 5 million euros. In order to optimize those investments, the following questions arise for the network operators. Where are the pipelines located, for example? What are their characteristics? When should we plan to replace them? What is the size of the future network? How can we best plan the construction sites? What is the value of my assets, etc., etc. For this, we have a digital decision-making tool. The Geographic Information System, GIS. And now I'm going to tell you a little story that has been a milestone for us in our GIS approach. In 2002, we acquired a new GIS software that worked to our entire satisfaction. But a few years later, an international company bought this GIS software and made major changes to it. When we wanted to make a simple update, it was no longer possible without a complete migration of our GIS, which corresponds to a very important financial and human effort. We then became aware of our lack of power over decisions concerning the computer code of our GIS software. With the agreement of our project steering committee, we decided to regain control over the computer code by developing our own professional modules to manage water based on open source technologies with QGIS as basic GIS software. QGIS is an open source software. But PUI small size means that we don't have enough resources to carry out those developments alone. This forced us to look for partners. This is how the cities of Lausanne, Montreux, Vevey, Morges, and Puy have come together to pool their intelligence, workforces, and finance. The diversity of our organization, political vision, different political vision, different corporate cultures, different administrative issues, different size, etc., etc., also forces us to constantly question ourselves and thus develop generic solutions. In other words, solutions that can be used by all cities and organizations. In order to not to depend on a single software publisher, we have networked IT developers worldwide, from Switzerland, from France, from Czech Republic, from Romania, Russia, Australia. In 2016, we put the drinking water management module into production. Then in 2019, we put the wastewater management module into production. After 4 years of code development in a project dynamic, which is illustrated at the left of the screen by those race boats, we launched, beginning 2020, a phase to develop the production process, which is illustrated by this cruise boat. That means something quieter, with quality, and which have a good guarantee of functioning. So concretely, this phase of production process, the goal of this production process are code piloting. This is the most important because we want to have this power on the code. Pooling of resources, human and financial, solution stability, and continuous improvement of the solution, and finally, guarantee of functioning for medium and long term. Concretely, the next steps are to renew the actual website. You can look at it on www.qwat.org. To add the wastewater module in the website, to rename the solution and the modules, to have a graphic line, complete documentation in 5 languages, to illustrate 2 or 3 main processes, to give access to the GitHub so that users can ask new functionalities, to have a business model, help desk, a convention where you have to agree to use those softwares, to have 1 or 2 users meeting every year, and to have a national organization, not at the level of the country, but at the level of cities. Finally, this project, we were surprised, but this project, in February, we went to the city of Nouakchott in Mauritania to realize a GIS diagnostic about water management and to analyze the way to implement our open source software solution, because they were very interested by this way of using software. And you have more information on this project on our website smart.puy.ch. And finally, so I hope I've managed to highlight the experience of a group of cities, little cities, focused to develop their own professional softwares and I look forward to sharing innovative ideas with you, and perhaps with the help of open source code, collaborate on this project in the future. For example, a first step could be to traduce the documentation in Greek language. Efkaristopolis.